Hello there, everybody. This video is kind of a follow-up to the previous one. There are two special right triangles, 45, 45, 90 and 30, 60, 90. This video is about 30, 60, 90 right triangles. And in the previous video, you learned that all 45, 45, 90s are similar to a certain triangle. It had the legs equal to 1 and the hypotenuse equal to the square root of 2. And 30, 60, 90s work the same way. All 30, 60, 90s are similar. Which means we can set up proportions to find missing sides. But what are they similar to? So, what triangle are they similar to? So let's see what where this takes us here. Here we've got an equilateral triangle. All three of these sides are the same. And since those are all the same, that means all these angles here are 60. And this one here at the top is 60 as well. Now, I'm going to draw an altitude down here, which means this is 90 degrees. And if I do that here, this thing has a line of symmetry, and I've just drawn it. And that means that these two angles are both 30. And so what we've got here on this left side and on the right side too is a 30, 60, 90 right triangle. So let's say, here it's 30. Let's say that this side is 2 units long. Well, this side of the original triangle is also 2 units long. And since this is a line of symmetry, that means each of these segments has to be the same. So this is 1. Because 1 and 1 is obviously 2. Now, how do we find this side? Well, we don't know a shortcut yet. So one way to do it would be Pythagorean theorem. We could go x squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4. Take away 1 from both sides, we get x squared equals 3. And we get x equals the square root of 3. There we go. So this side here is the square root of 3. So this 30, 60, 90, I'm going to erase the rest of this here. This 30, 60, 90 is similar to any other 30, 60, 90. So we can use that. Whenever we have a 30, 60, 90, we know it's similar to this one, and we can use that to set up proportions to find missing sides. We use Pythagorean theorem here, but that will not always work. We need 2 sides in order to use Pythagorean theorem, and we won't always be able to figure out 2 sides in one of these problems. So I'm trying to give you a method that will work all the time. So I'm going to encourage you to set up a proportion to find these missing sides. So let's take a look here. Here we've got a couple of 30, 60, 90s. This 30, 60, 90s here, we know that this side is 10. Now these two triangles are similar. They both have a 90 and a 60, and really a 30 for that matter. So they are similar by angle. That means we can set up a proportion to find x and y. Now, so which side in this original triangle matches up with 10? Well, 10 is the hypotenuse, and 2 is the hypotenuse up here. So we can set up a proportion where we have 10 over 2. Now let's say we wanted to find x. So let's get rid of that x up here so we know what I'm talking about. Talking about this x. So x on top. And x is the smallest side in this triangle. That's 1 up here. So we're going to put x over 1. And now we've got a proportion that we can solve. And a pretty easy one really too. So we got 2x equals 10. X equals 5 when you divide both sides by 2. So this side is 5. Now, eventually you're going to start to see shortcuts with these problems, with the 45, 45, 90s and the 30, 60, 90. I would encourage you to look for these shortcuts. I want you to find them. I'm not going to tell you how to find them because I think if you figure them out yourself, you will learn them better and you'll be more likely to remember. So know that these proportions will always work. And until you find the shortcut, set up the proportion and solve it. It will always work. Okay? Let's find y here as well. We can use 10 over 2 again. So 10 is the hypotenuse here, 2 is the hypotenuse here, so 10 over 2. And if we're going to find y, it's going to go there. And y is kind of it's not the hypotenuse and it's not the shortest side, but it's this kind of middle side in length. And that's the square root of 3 here. So we're going to put y over the square root of 3. Again, we've got a proportion that we can solve. We go 2y equals 10 times the square root of 3. Divide both sides by 2. We get y equals 5 times the square root of 3. And there we go. This side is 5 times the square root of 3. All right, let's take a look at this other triangle here. Also a 30, 60, 90. And we know this bottom side here is the square root of 5. And we want to find those other two. All right, well, let's say we want to find x first. So x goes with the square root of 3 in this triangle up here. These triangles are similar again because they have the same angles. But this x, that's kind of a longer of the two sides that meet at the right angle. And it goes with root 3. So x and root 3 go together. Let's make a ratio. X over root 3. There's that. Now, root 5 is the shortest side, and it goes with 1. So we're going to do root 5 over 1. Now, notice I did this triangle over this triangle and this triangle over this triangle. You kind of have to go in the same order, but so now we've got a proportion that we can solve. We go x times 1 is x, and root 3 times root 5 is the square root of 15. Easy. Easy as that. That is all you have to do. Let's do a similar proportion to find y. Now, y is the hypotenuse. That goes with the 2. So we're going to go y over 2. So you can see that. I can use either of these two. It doesn't really matter. Let's use the 15 just for the heck of it. Or root 15. So root 15 goes with root 3. So we're going to say equals root 15 over root 3. You'll get the exact same thing as if you use root 5 and 1. You get the same thing. Let's see what we get. We get y times the square root of 3 times y equals 2 times the square root of 15. So now I've got to divide both sides by the square root of 3. And these root 3's cancel. I get y equals, now root 15 divided by root 3 is root 5. So I get 2 root 5. So this up here is 2 root 5. And there we go. That's it. Remember, all 30, 60, 90s are similar to this triangle. So you can always set up a proportion to find a missing side. Remember, there are shortcuts. If you can see them, use them. And when you figure them out, check and make sure they're right with your teacher.